So we're trying to differentiate. So here's what I would do. I would not use the product rule here. I will distribute. And remember, when I multiply x by the square root of x, I get x times x to 1/2, because that's what the square root of x is. So this product, x times the square root of x. And then 1/2 plus 1 is 3/2. So when I multiply these two, I get x to 3/2. And obviously minus 10, x to 1/2. There is no really need to change the square root, but this is easier like that. But here I don't really have to change 10 to x to 1/2 because I know the square root of x prime is 1/2 the square root of x, so there is really no need. So you can keep it like this. So then y prime, or dy over dx, will be bring down the power, subtract 1 from the power, right? Bring down the power, or just say negative 10, the square root of x prime is 1/2 the square root of x, and I'm done.
Now, how you wrote that y prime equals dy over dx?
Yes, this is, there are different notations. We're going to use this notation today, so I want you to get used to it.
Do you want us every time that we do?
No, absolutely not. You don't have to write both, of course. Thank you. I'm sorry, my apologies. Yes, Brian?
That was simplified to 5.
Oh, yeah, we didn't finish.
Oh, I'm
Oh,
sorry.
yeah. We didn't finish. So then we have 3/2 the square root of x. Oh, I'm sorry. We have 3/2 the square root of x minus 5/2 the square root of x. And I will have to continue. It is recommended. If I can simplify it, I should. So then the least common denominator, so this is 1, of course. I'm trying to do 5 things at the same time, and that doesn't work. Okay, so indeed we simplify by 2, and we get 5 over the square root of x. And now the least common denominator is 2 the square root of x. This one needs a square root of x, and this one needs a 2. I didn't want to simplify because of that, but yeah, that's fine. It's no mistake. So then this is 3x minus 10. So I should always try to simplify if possible. Very good question. Yes, please.
So in WebAssign,
Yes?
I think that's might be what it's confirmed, right? The answer for that it needed from me was 3/2 x to the 1/2 minus 5x to the negative 1/2.
That's fine.
Okay.
But they will have to accept this one as well.
Oh, it would? Okay.
Just give it a shot and let me know.
Okay. Yeah.
Absolutely mandatory. They have to accept this answer. Otherwise,
Okay.
we, as my colleague said, it breaks math. No, absolutely. It has to accept both.
Okay.
And by the way, I will insist that on a problem on a test, you fully simplify it.
Okay.
Negative exponents are not a good thing in the final answer. For the most part. I'm not going to carve it in stone and say never. But in general. Good. Thank you for bringing this to class, Sean. Anything else? Other questions? Anything?
I did have another one.
Yes, please. I'm ready.
There's a find the second degree polynomial p such that p. I'll just hand it to you.
Yeah, we did a problem like this in class, if you remember.
Oh, that's my bad.
That's okay. So p of 2 is 9. P prime of 2 is 9. P double prime of 2 is 6. Good. I just, when you get to my age, you need to check stuff. So I thought we did this. Just making sure I was in the right class.
We sure did.
We did?
be sure.
P of 2 equals 5.
63 on page
Right.
Yeah.
Right. But it doesn't matter. If you would like us to, yes, we did. Okay. So if you'd like us to work on this problem, at least let's get it started. Okay. So remember the most general polynomial degree 2 is P of x equals, and we have to remember that, is ax squared, yes, plus bx plus c. Perfect. So from here, so obviously I do not have these parameters. So once I determine a, b, and c, then I determine one, a unique, just one polynomial that fulfills the given conditions. So therefore, I have to be given, or I have to determine 3 equations. So indirectly, I'm given these 3 equations. So the first one, blah, 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 equals 9. Can anyone tell us what to write on the left-hand side?
A2 squared.
Very good. So 4a plus 2b plus c. This is the first equation. Is this understood, everyone? Please stop me if you have questions. Okay, let's find the first derivative first. So p prime of x, can anyone give us, using the formulas, the definition, I'm sorry, the differentiation rules?
2a
Very good.
plus b.
Good. And then from here, p prime of 2 is 9 as well. So what do we have on the left-hand side? Very good. And then let's determine the second derivative. So that equation would be 2a equals 6. So this is one equation, here's the second one, and here's the third one. 1, 2, 3. Putting these 3 together, do you think we are going to have any difficulties finding a, b, and c? You have a from the last one, which is 3, you plug it in, you find b, and then you plug in a and b to find c. Would that be enough? Also, just one comment I don't want to forget about your test. Please write measurement units. I think I wrote so many different measurement units that you didn't come up with. So please write measurement units. The other thing, when a limit is a number over 0 and it approaches -3 from either side, you must present both sides. You cannot just say d and e, you have to show y. So please remember that. Measurement units, please remember that. Measurement unit. What else I was going to say? Always explain or quote the theorem you're using by the squeeze theorem. Okay, measurement unit, percentage of charge, whatever, per hour. Also, when you find something, you have to create the function and you have to write the function. Not just say, okay, at 3 is 5. I gave full credit, but I would like to see the function. Not just say, okay, such and such. Also, don't forget about continuity. You must write, only Brian here wrote that correctly. I gave full credit, but I should give him more, actually, because he did write these two, they must be continuous, and they are as polynomials. And then he wrote the a definition of continuity at a point. And then also, I did not see, maybe he did, or maybe one of you did, you have to write the function. You have to just, not just, okay, c is 11. You have to put it back in and write the function one more time, this time with c equals 11. So please make a note of that. I didn't, okay, here, I was only expecting you to write this limit and write 40. You don't know how many times I had to write grams per liter. Please, measurement unit, please. That's all you had to do. You could have used, factoring out the denominators. I did. I factored out t, I simplified, and I got 40. Okay. Here, you cannot plug in the slope 4x minus 3. Some of you plugged in, replace the slope by 4x minus 3. The slope has to be a number. You have the derivative. This is your derivative. determine it at -2, it's -11, you plug it in. Okay, that was one other comment. Was there anything else? I really would like to see a summarize of this information. Again, I did not deduct points. If you had the correct graph, I gave full points. But many of you put a full point here, a full point here, and a full point here, but that's not a function. By the vertical line test, will not be a function. So careful on that. Here, we specifically said if the factor goes away, this cannot be a vertical asymptote. Only one student, I think, maybe two, correctly identified this limit 1/7 and wrote 6, 1/7 is a whole. So please, please, please. Okay. And again, the smartest thing to do was to do problem C. Only one student did problem C. You went for the difficult, they're not difficult, but this was the easiest. And again, only one student went for the last one. So, questions? Thank you. Okay. Sean, is this good enough?
Yes.
Okay, perfect. Before we go back to the quotient rule and the product rule, etc., and move on from there, I would like to present something that is in chapter 4, but I can't wait. I mean, I can, but I don't want to. How many indeterminate cases have we encountered so far? 3. We encountered 0 over 0. We encountered infinity over infinity. And we encountered infinity minus infinity. And there are 4 more left. And Randy, if you'd like to add up your points, make sure by the end of the day today, if there is any error, don't get upset. I'll check it. I'll change it. And okay? Good. Okay. And make sure I graded everything. Sometimes if the phone rings and, sometimes it happens that I omit something and I don't want to. Okay. Only in these 2 situations and no other, there is a theorem or rule that can be applied only when we talk about limits. Only limits. So, of course, when we have 0 over 0 inside a limit or infinity over infinity, it's called L'Hopital's rule. What did he say and proved? He said this, that the limit of a function divided by another function when x approaches a, from one side, from the other, or from both, it doesn't matter. If it is this or this, only in the case of 0 over 0 or infinity over infinity, we are allowed to do this. We never differentiate a ratio by differentiating the top and differentiating the bottom. That's never allowed. However, inside a limit, and if we encounter one or the other, not this and not any other of the 4 ones, just these 2, we are allowed to determine the limit by differentiating the top and differentiating the bottom. So we should all remember by now that when x approaches 0 from either side, from sine x over x is, and a long time ago when we looked at this, I said I can't show you why, so we looked at the graph. But we do remember that this is, maybe not, maybe we didn't look at it. We didn't look at it at this limit, right? Okay, we did not. Then leave it alone for a minute or 2. Okay, we're going to get to it. So I put it there. So okay, so good. In y equals, let's put the function sine x, close the parenthesis, divided by x. And where do I want to graph or see the graph? Near what? Only near 0. I don't care about what happens outside. So I'm going to choose -1 to 1. with a scale of 0.5. And y minimum -2 to 2, maximum 2 with a scale of 1. That's good enough. Here it is. And there must be a blip in here, because if I go back and put in 0, what's going to happen? Oh, I'm sorry. I keep forgetting. It was a deep freeze on this computer. Okay, so what do you think is going to happen when I put in 0? Of course, I can put in 0. Good, so let's look at the graph again. So what do you think the limit from either side as x approaches 0 from sine x over x is? 1. Good. Okay. Now let's say we don't know the answer, and I want to apply L'Hopital's rule. We plug it in. What do we get at the top? Perfect. What do we get in the denominator? Okay. Can I use L'Hopital's rule? Yes. And we will determine it as sine prime over 1. We don't know what sine prime is, but since I started and now I have no choice, I have to finish. So we're going to look at this today. When x approaches 0, I'm telling you sine prime is cosine. And how much is cosine? Where does cosine go? Left and right of 0. So this is L'Hopital's rule. However, I'm going to do this again. Don't worry about this particular one, but I want you to give me any limit from the past that was 0 over 0 or infinity over infinity to illustrate with one example. We're going to have plenty. We're going to use this moving forward a lot. But I just want you to pick one problem from the past, one limit, just limit from the past that was infinity over infinity or 0 over 0. So we can illustrate L'Hopital's rule one more time. If not, I would pick one. Yeah, why not? I want to pick this one. Okay, ready? Good, so it's 1 minus 2x squared, so that's limit as x approaches infinity from 1 minus 2x squared minus x to the 4th divided by 5 plus x minus 3x to the 4th. And please tell me where the top is going. Right, because these are too small when x approaches infinity. So this goes to infinity, but there is a minus in front. But who cares about the sign, really? The sign is not a problem in this case. And the same thing in the denominator. And now I have L'Hopital's rule. Let's differentiate the top. This is the only time when I differentiate a quotient top prime over bottom prime. I'll never do that, ever. But inside a limit, only because it's infinity over infinity or 0 over 0, I am allowed to. Just one time. Good, so let's differentiate the numerator. Very good. Let's differentiate the denominator. Excellent. Now please tell me what this is. Where does the numerator go? The denominator. I can apply the same rule again. Limit as x approaches infinity. Plus
12x.
It's minus. Sorry, it's minus. It's minus. Okay, what about the denominator? Good. Negative 36x squared. Good. The numerator goes to? Good. And the denominator as well. Limit x approaches infinity. The numerator prime?
-24.
the denominator prime. Now I'm allowed to simplify. I could not, they were not factors. I can simplify x with x. And the final form is 24 over 72, which is 1/3. You can say, but this is much longer than the other one by simply fact. That's fine. I just wanted to show you how L'Hopital's rule is applicable. Yes, I agree. Factoring out x to the 4th at the top and the denominator is just one line answer. One line solution. This one is 4. If you write it, it's probably 2. But when I write it, it's 4. Sometimes 4.5. Okay, good. So that's L'Hopital's rule. So moving forward. Now, yes, please. Yes?
What is 1/3 in this? So that's the
Yes. So y, no. Y equals 1/3 is the horizontal asymptote of this function, rational function. This doesn't mean anything. This is just the horizontal asymptote. We are determining the limit of a function as x approaches infinity. And since the answer is a number, not infinity, it can be 0 or any number, then we know that y equals 1/3 in this case is the horizontal asymptote. This is not the derivative. Also, thank you for reminding me. I just wanted to make one more comment. When I was asking you to here to determine the derivative, you have to start with this. This is your starting point. I saw something like this without the limit. I saw this without f prime. No. This is the starting point. F prime equals this. I did not deduct points. I knew what you were trying to do. I understand. You know, an exam is an exam and we're all nervous about it and so on and so forth. But this is the way we have to start. Please, when you're asked to find the derivative using the definition, you have to write f prime. You have to write this and then everything else follows so I can follow your answer. But something like this is incorrect. You cannot just write this and then come up with 4x minus 3. Because the answer here without the limit is 4x plus 2h minus 3, not 4x minus 3. But if you put the limit, then it's a different story. H approaches 0, that's how you get the 4x minus 3. Without the limit, it makes no sense. I mean, it makes sense in the sense that you're only determining the difference quotient, but you're not determining the derivative. So remember, they go together. 1, 2, 3. Ready? Clear? Okay, perfect. Okay, so let's go back to the quotient rule and the product rule before we move on to the chain rule and the derivatives of trig functions. So we are still in 3.2. And I'm looking back to the notes here. And we did not look at any examples. So I'm going back for a second. So product and quotient rule, I presented them and I only used one example to show you how to apply the quotient rule. So we didn't do anything, basically. Okay. So let's choose products, quotients. Now, absolutely, I have to show you a product and anything else you'd like. These are not super sophisticated types of problems till we get to the chain rule and implicit differentiation, which will be a little bit more intense. But here you can choose anything, product or quotient.
Do you have any recommendations?
So we did something similar to 14. We can just choose a product if you'd like. And we want to look at 17? Okay, perfect. I don't think anyone has ever picked 17. Good pick. Yeah. I don't think so. So 17 on page 189. And we have y equals e to p and p plus p, the square root of p.
This be equal
Say it again.
the other notation instead of
Yes, so you can use y prime or you can use dy over dp. Now this is I really don't like this. I prefer this, or I prefer this. So if I have to choose among these three, I would prefer these two, not this. Why? Here's why. This is very clear. We're talking about a function that has the independent variable p. Very clear. Here it's the same thing. You are differentiating the function y with respect to p, which tells me very clearly that y is a function of p, or the independent variable inside y is p. But this one doesn't say much. Okay, so we are using the product rule, but I want to prepare this function a little bit. I don't like this because I will have to use the product rule. But I know we did few minutes ago, x times the square root of x is x to 3/2. Of course, in this case, I have p, but I'm just reminding you that we had a previous question a minute ago. So it was the square root of x times x, or p times the square root of p, or the square root of x times the square root of x, the same thing as x to 3/2. So I'm going to change the function into that, and then I'll come back to this. So it will be e to p and p plus p to 3/2. This is what I prefer to differentiate using the product rule. Because otherwise I would have a product and inside of it another product, and there is no need for that. So now we're ready to differentiate. It's a very good problem. Thank you for picking that. So I differentiate the first function. So let me refresh your memory. When we have a product of two functions, and you do not have to use my method if you are comfortable with a different one, I keep them in the same order so I don't forget anything. But that's me. So you may have a different method, and I respect that. So the first function prime times the second one plus the first times the second prime. I don't twist this. I don't twist that. I keep 1, 2, 1, 2, 1, 2. But it's up to you. So when I differentiate the first function, we said that e to p prime is the nicest function, or e to p is the nicest function because e to p prime is e to p. But then I have to copy p plus p to 3/2. So that was a derivative of the first function, and then I copied the second one, and I'm here with plus. I copy the first one, and I differentiate the second function in parentheses because p prime is 1 plus I bring down 3/2 and subtract 1 from 3/2, which is the square root, or 1/2. I would try to simplify it a little bit by factoring out e to p. Now it's p plus, and I can go back to p the square root of p. I know that this came from that. So p to 3/2 is the same with p the square root of p, plus 1 plus 3/2 the square root of p. I'm looking at it, and there is nothing really I can do any further. I can't take that. Even if I factor out, there is nothing I can do, so there is no need. But that's good enough.
Is there any real reason to not write it as p plus p to go to just keep it out of keep it out from the radical, keep it in the exponential form?
I changed it into radicals to see if I could factor out anything or combine like terms. But if I have the power like that, I can't really combine like terms. So that's why I changed it back into radicals. If I had a p here, for example, I would have combined these two. But I don't. So they are not like terms. They have the same irrational part, but they don't have the same variable in front.
So going back to
Yes?
the terms, you have 1 and 2 at the very top. 1
Yes.
prime times 2.
So this is number 1, and this is number 2,
Okay.
or this. So then the first function prime is e to p, and then I copy the second one, and then plus. I copy the first one, and I differentiate the second one. 1 plus 3/2 p to 3/2 minus 1. Is that okay? Yes?
I'm fine.
Better?
Makes sense.
Okay. Let's continue with we will have enough, plenty of examples with the first and the second derivative. So I would like to talk about this: tangent line and normal line. So let's choose one of those two problems and talk about the tangent line and the normal line. And then we'll look at some applications on the next page with graphs and maybe something else. 34? Very good. So let's take a look at 34. In 34, we have y equals 2x. Everything divided by x squared plus 1. They're giving us a point 1, comma 1. And this is 34 on page 189. Okay. So let's say we have a function. This is f of x, and let's suppose that this is the point P, 1, comma 1. This is the tangent at P. And at the same point, this is what is called the normal line. Of course, they are perpendicular at that point, 90 degrees everywhere. And we are asked in this problem to determine the equation of the line, of the tangent line at P, as well as the equation of the normal line at P. Where is our starting point?
Finding the tangent.
Correct. Of course, very good. So y prime, there is a constant at the top that is a factor. If it were 2x plus 1, I could have not done this. But since it's a factor, I want to get rid of it. I want it to wait for us patiently outside because it's a factor. So imagine this function can be rewritten as 2 times x over x squared plus 1. So this is the constant times the function. Simplifies things a little bit. That's all. The top function prime, so let me write the formula that I'm using here. 1 over 2 prime is the same thing as I just used, but with minus, over the second function squared. Same order, everything the same, but it's minus. So that's the quotient rule. First function prime times the second function minus the first times the second function prime over the second function squared. So I copy 2. Top function prime is 1 times x squared plus 1, but minus the first function times the second function prime. What is the second function prime? Thank you very much. So from here, I'm going to continue here because I know I'm going to run out of room. So 2 is patiently waiting. X squared plus 1 minus 2x squared over x squared plus 1 squared. So 2 quantity negative x squared plus 1 over x squared plus 1 squared. And yes, by now you know me, I'm not going to slip tight with that negative leading coefficient in there. So I'm going to write negative 2 x squared minus 1 over x squared plus 1 squared. Okay, so fine, you're going to say. So y prime is negative 2 x squared minus 1 over x squared plus 1 squared. So what? Okay, you found the derivative. Now what? What am I going to do with this? Very good. When x equals 1. Why? Because I'm trying to find the slope. So I have to plug in 1. The x coordinate, not this one, but this one. Okay, so what do I get when I plug in 1? See, because I simplified it to the fullest, it's so much easier to determine this. What is the answer?
0.
Excellent. 0 indeed. Okay, so then I have y minus y1 equals the slope times x minus x1, where this is 1, this is 0, and this is 1. So y minus 1 equals 0, which means y equals 1. If the tangent at that point, so this is the point 1 comma 1. If the tangent line to the graph of this, I didn't graph the function, is 1, y equals 1, can anyone give us the equation of the normal line? Right. There is no other way. If the equation of the tangent line, or if the tangent line is horizontal, the normal line has to be vertical at that specific point, at the point 1 comma 1. Why did I write this? I'm not sure. I meant 1 comma 1. That's the point. Any questions? I talked about one-to-one functions in my previous class, and that's why in my mind I wrote one-to-one, not 1 comma 1. Okay. Any questions? Okay, I would like to read from a graph before we move on to derivatives of trig functions, either this or this. And also I would like to determine, like, for example, carefully look here. Any part of this problem you like to pick. If a function is differentiable, find an expression for the derivative of each of the following functions. Any of these. Also, if you'd like any of these or these, same thing. And also read from a graph, just to make sure that we understand what we're trying to do. What would you like to pick? 1, 2.
Can you shift the page a little bit to the right? One of these, 52.
Yes, which one? Which one?
52.
Which part?
A.
A, very good. X squared f of x. So let's start with 52a. On page 191. And again, we have a function called y equals x squared f of x. We are told that f of x is a differentiable function, and we're asked to find y prime. This is the product rule. This is for function 1, and this is function 2. If you're using my method, then you will say 2x times f of x and plus x squared times f prime. Remember, when you apply the product rule, you should always have a sum of 2 terms as the final answer. Okay, so let's look at also 44D. And 44D, we have a function h of x, which is g of x divided by 1 plus f of x. And we're given a lot of extra information because the question is asking us to determine h prime of 2. But they're giving us f of 2, which is -3, g of 2, which is 4, f prime of 2, which is -2, and we are given also g prime of 2 equals 7. How do I address this question? Yes, I have to find h prime of x first. I cannot plug in anything before I find the function, which is a h prime. Okay, so let's differentiate the top. Then we get g prime of x multiplied by the denominator minus the numerator times the denominator prime over the denominator squared. Can anyone give us the numerator prime? I'm sorry, the denominator prime, of course. So the top function prime times the denominator minus the top times the denominator prime, which is f prime of x. Only now I can find h prime of 2. Quite simple from this moment on, because it's g prime of 2, 1 plus f of 2 minus g of 2, f prime of 2, 1 plus f of 2, and everything squared. Once I have the function, everything else is easier. So let's plug in the numbers. What are the numbers? So let's put them in. G prime of 2, 7. F of 2, -3. G of 2, 4. F prime of 2, -2. And f of 2, -3. So then this is 7 times -3 plus 1, -2, minus 4 times -2, and everything over 1 minus 3, which is -2 squared, which is 4. Do not attempt to simplify 4 with 4, please. So we have -14 and plus 8 divided by 4. -6 over 4, or -3/2. So the slope of the tangent line to the graph of function h at x equals 2 is -3/2. The rate of change at that point is -3/2. Any questions?
So this is h prime 2.
Yes, the rate of change at 2 of this function. Okay, I know we've looked at something like this before. Would you like to look at another, or we move on? Yes, which one? 50. Part A or part B? B. Very good. So first of all, part B is Q of x, which is a ratio f over g. So let's determine what this means first, because otherwise I can plug in and then see what is required for Q prime of 7. Okay. So we have h. It is. For functions are f and g. Okay. So it's, okay, q, yes. They denoted by q. So this is problem 50 on page 190. So q of x is f of x divided by g of x. And they're telling us that they are differentiable, of course. And,
Could you zoom out for us?
oh, of course. Sorry. Sorry. And they want us to find the q prime of 7. So when we find q prime of x first, remember we have to use the quotient rule. Top prime, f prime, times the denominator minus f times the denominator prime over the denominator squared. Now, however, it's pretty similar to the previous problem, but we are not given numbers. We have to determine them from the graph, the two graphs of f and g. Okay. So then I can just write what I need so far. See it here. So q prime of 7 equals f prime of 7 times g of 7 minus f of 7 times g prime of 7 over g squared of 7. Of g of 7 squared if you want, if it's better, it sounds better. Okay, so I want f and g at 7 and f prime of 7 and g prime of 7. Okay, ready? Now let's take a look. F of 7. F is in red. 1, 2, 3, 4, 5, 6, 7. So that's where 7 is. Sorry, I'm writing with my left hand. So Brian will be proud of me. Okay, so at 7, F is 1, 2, 3, 4, 5. Okay, so F of 7 is 5. I have to hold it. If I don't hold the book, will fall off. Okay. G of 7, please. G of 7 is 1. Good. And now I want to determine f prime of 7. Obviously, at 7, the derivative is positive. And I would like to form a right triangle using these points of the grid, right, where it's because it's easy to read. So I read 1 divided by 4. So f prime at 7 is 1/4. Good. And now g, of course, I see it's a negative slope. So at g of 7, again, I'm going to form this triangle. So I see a rise of 2 and a run of 3. So that will be negative 2/3. G prime of 7. Okay? Questions? We see that? Any questions? Anyone? Okay, so let's put them in, and this is it. So I got f of 7 is 5. I got that g of 7 is 1. I got that f prime of 7 is 1/4. And I got that g prime of 7 is negative 2/3. And g of 7 is 1/1². Okay, so 1/4 times 1 is 1/4. Negative 5 times negative 2/3 is positive 10/3. And divided by 1. The least common denominator is good. So this one needs a 3 and this one needs a 4. So 3 plus 40 is 43 divided by 12. And 43 is a prime number. So the rate of change, the instantaneous rate of change of function q when x is 7 is 43/12. Any questions? Is this okay? Ready to move on? The derivatives of trig functions. sine x, cosine x, tangent x, cotangent x, secant, and cosecant. Okay, we can take either sine or cosine and prove it from the beginning till the end using the definition, if you'd like. It will involve a lot of trig identities. It's up to you. It will take about 7 to maybe 8 minutes. Or you can say, we don't want to waste the time. It's not a waste, but we don't want to spend the time on that, and just give us the answer. It's up to you. I always give my students an option. You want directly the formula, or you want to go through those steps of one or the other, either sine or cosine. Once we have sine and cosine, these are ratios, and we will be able to determine the derivative very easily using this, the definition, using not the definition, but the differentiation rules.
Steps.
You want to see? Okay, which of these two you would like to see? Sine. Very good. So we'll come back to that list. So our function is a sine x, and we want to find f prime with a definition. So see, we have to write f prime, we have to write the limit as h approaches 0, and we have to write f of x plus h minus f of x divided by h. These 2-3 steps, if you like, are mandatory when you are asked to determine and put it in writing step by step when you're asked to determine the derivative of a function using the definition. Okay? Without the limit, makes no sense. It's not a derivative. It's just the difference quotient. Okay, so then I continue with limit h approaches 0, obviously sine x plus h minus sine x divided by h. So this is our first identity that we will be using here. The first identity, I just want to check the time on the video. 52, okay.